Please confirm if you can hear me. Can you guys hear me?
Yes, you can.
Okay.
Yes.
Okay, yeah. So good evening everyone. So okay, for today's class, we'll just be going over the basics of Git and of Git and GitHub, which is like kind of very, very important when it comes to not just even bioinformatics, but like kind of programming as a whole to help us keep track of whatever thing we're doing. So that's what we're kind of maybe going to basically walk through for today. Now that we're done with the Unix command line and then the bash scripting aspect. So we'll be doing like kind of an overview of the key concepts of Git and GitHub, and then we'll walk through how to install Git on our local computers, and then how to use it to work on that's back and forth on GitHub. So we'll be covering the GitHub basics, and then we'll do like sort of some demo too, and then I'll be giving us an assignment, or let me just call it a quiz for today, and then that will be that for today. So we'll still continue tomorrow with Git and GitHub, but then like for today, we'll just do kind of a general overview of what it's all about. Okay, so these are the key concepts I'm going to cover: the version control, what version control really means, and then what is Git, and then what is GitHub. So like in bioinformatics, okay, let me just start with from the general overview of what a version control system actually does. So let's say, for example, now like our normal documentation on our systems or wherever, where we kind of keep track of whatever changes we make to our documents. So let's say, for example, now I'm trying to maybe write an essay or a thesis or a project, and like most of the time, but like we do end up having like, okay, a version one of our projects, a version two, version three, like maybe like based on the changes that we make like along the line. So like we really like kind of tend to have that. So for bioinformatics, where most of the time we tend to you know like do lots of stuff, and then using that kind of method of documenting like the kind of versions that we have, maybe version one, version A, version B, C, D, E, it could be endless. It's not that reproducible, and it's not it's not very nice for automation. So like what version control like actually does is like it helps us to like kind of maybe find and kind of a smart way to kind of keep track of all those changes that we make along the line without having to be saving like one after the other. So like back to like maybe the story, like this was actually built like the one that we're going to talk about today. That's a version control system that we're going to talk about today, which is Git. Was actually built by the guy that also wrote Linux. I think what's his name again? Linus Torvald, correct me if I'm wrong. So he was the one that actually wrote Git on his own end to help him keep track of kind of the project he did for as why writing Linux and all that. So it's basically like kind of a smart tool that helps us work together on projects, especially computer programs, and then to keep track of each step of what we do. So it keeps track of changes made to files, kind of saving different versions of the document, just like what you said not long ago. So instead of having to save with multiple files, version one, version two, so this gives us the power to have to be able to access any version of our file whenever we want, going forward. So it's like having a time machine for your work. So you can always go back in time to access maybe like an older version of your file. So like a good example would be okay, let's say for example now someone does a project, okay, maybe writes maybe a number of scripts, joins them together maybe to perform a particular automated task. And at the end of the day, maybe like let's assume that that project is supposed to maybe like kind of maybe compute a particular result. Let's say for example, now I'm writing a script that at the end of the day I'm supposed to have maybe like 14% as the output of that program. And then I find out that maybe in 2 years' time, I come back to that script. And then when I run it, instead of having that result I had kind of initially, maybe like 14%, I end up having maybe like 20% at the end of the day. So like I'll be wondering like what went wrong with my code. So if in that scenario now, like let's assume you use the version control system. So you can easily like kind of maybe like kind of go back to the workflow, maybe to test each step one after the other, maybe to confirm the particular point where that's maybe the particular point which is causing that particular error, maybe in your results. So keeping you like in track and then giving you like the power to maybe go back to whichever step you want to go back to in that your workflow. So for the version control system that we'll be talking about today, which is Git. So Git is like kind of just a command line interface based tool which you can use to document each step of our work, or maybe any changes to make to our files, or to document every version of code that we work with along the line. So we can work on it. We can use it on our command line, just like what we've been doing, like all these on our command line. So we can install it and then use it to keep track of whatever thing we do going forward. So as a version control system, it is used to track repositories. So repositories are just like kind of directories that we normally make. That's why we're working on the command line. So while we make changes in the directory, while we make changes to a file, we can use Git to kind of keep track of whatever changes we make in that particular file. So like it's like kind of a good a means of documenting, whatever we do. And then going forward, like would even get like kind of maybe get to see why it's also good in terms of collaboration. Let's say, for example, now we have so many people like that have access to a particular repo, and then you would want to keep track of whatever change that each person makes to that reposition. Like Git helps us to do that. So and then also it helps us to track changes in files with the ability to have different branches. So like when we talk about branches in GitHub, so uh so let's say for example now I open a directory now to maybe work on a particular project and then keep different files there and then make changes to them. So apart from having just just a single repository that you can use to perform and carry out a project, like Git also like kind of maybe gives us the access to have other branches in that particular kind of repository. So just think of it like in terms of having like kind of a tree that has branches. So whereby you might want to maybe have maybe independent repos that you'd want to manage separately, and then at the end, and then at the and then at the end of the day, you now want to kind of maybe merge all of them together. That's to maybe a common project. So like it also gives us the power to kind of diverge different projects, and then maybe like even work independently from the main repo that you are working with, and then at the end of the day, you can maybe decide to maybe merge them or leave it the way you had it before. So Git gives us that power. So it really has like kind of different functionalities which you can already see on the screen here. So we'll get to see how each of these options work that is going forward. So how we can use Git to add files, to commit them, to push them to GitHub, to pull changes you've made on GitHub down to your local computer, and then how to merge different branches and more. So like I said before, like a repo, don't mind the sticker or the meme stuff. So like just the same way you make your directories on on your local computers, so you can also make your repo which helps you to add files and then keep track of them as you work. So we've talked about branches, having different branches for a particular project, which you can merge later on in the future. So, and then we talk about committing. So like the way GitHub works is that, okay, like it has like kind of series of steps that you have to follow for you to keep track of a particular file. So like first of all, whenever you want to keep track of a file, you have to commit it in the hands of Git. So if you don't commit a file in the hands of Git, like you won't be able to track that file. So like you must always commit a file with Git. Kind of, should I call it? Should I just like what we are seeing here, like on the sticker we are seeing here on the screen, like kind of you have to like kind of should I call it a confidence or maybe just reach an agreement? So say commit that, okay, I want Git to keep track of this file for me. So that is what like the commit functionality for option does for us. And then whenever we talk about push in Git, it's just simply trying to push whatever changes you've made on your local machine to GitHub. So we'll talk about GitHub later on. So which is like kind of a should I call it a marketplace of different people, like different people working with Git. You get, so we'll get to talk about GitHub. So and then pull, which is trying to pull changes you've made on GitHub down to your local computer, and then how to merge branches and more. So this is just like kind of another meme on maybe to help us understand this. So like I said before, you I think I missed out on something. I missed on add. I didn't mention add here. So before you commit a file, you have to add that file to your repo, right? And then commit it and then push it to GitHub, or you pull changes you've made up from your GitHub down to your local computer. So like in the proper order now, like this meme is just trying to say that like on a normal you have to add a file, commit it to GitHub, and then push it. So, sorry, commit it to Git, and then you push it to GitHub. But then if you just maybe have some files in your repo and then you don't add it first, you don't do Git add and then just commit and push. If you want to maybe track changes, you like kind of find out that, okay, this particular file will not be like Git will not, it's not going to like kind of keep track of it. So like they will just be left behind on your local computer. I will be able to see it on GitHub if you try to check that. So you always have to add your files with Git and then commit before you push to GitHub. So this is just like kind of trying to kind of let us know that Git is totally different from GitHub. So like Git on its own is just like kind of a command line interface tool that helps us to keep track like kind of all of those files we get. While like GitHub itself is like kind of maybe a kind of an online social coding service that is based on Git. So whereby like different people like kind of making use of Git to keep track of their files can also collaborate on the platform, which is GitHub. So on GitHub, where several people like kind of store their their repos, you can see what they do, you can make a copy of what they are doing and then work on this on your own end, and then do like even sync what you are doing and kind of on your local computer back to the repo you have on GitHub. So GitHub repos can be cloned to any system that has Git installed. So as far as you install Git on your system, just like every other tool, like you have the power to clone maybe whatever repo that a user has made accessible to the public on GitHub. You can always clone it down to your system and then maybe study what they've done or make some changes and then maybe just do whatever you play around with it basically. Okay, so this is just a workflow of what I've been talking about since. So I have a working directory in my local computer. I have a GitHub account with Git, and then I want to maybe kind of keep all of them like in sync as I work on a project. So once I open my directory and then maybe start adding files and then making changes to them, if I want to commit, kind of maybe help, kind of use Git to keep track of those files. Like first of all, I need to add whatever I have in that working directory. Kind of, it's called like kind of staging. You want to stage all those files for change. You get to track them for maybe in the future. So like first of all, you have to stage them by using git add. That's the name of the command. So you have to stage them with git add. So once you've staged, then you can now commit all the things that you've staged in the hands of Git, still in your local Git, in your local Git in your computer. So once you've done that, then you can now push all of the changes you've made down to GitHub. Either all of the changes you've made, or then maybe even those you selected, because apart from just adding everything in your working directory, you can always select what you want to add and then stage them for changes by committing and then subsequently pushing to GitHub with git push. So the same way you did this, that you push changes, should in case you make changes in your GitHub, that you sign into your GitHub account and then make some changes, maybe add files and maybe edit files on your GitHub. You can also sync what you have on GitHub down to your local computer by using the pull option. So we'll get to see all of these during hands-on. Please, I hope you guys are following. If you have any question, you can ask now before I go further. Any questions so far, please, you can unmute and let me know. Okay, I guess not. Okay, so still on the workflow of GitHub, so we have something called forking. That's to fork a repo. So like whenever you talk about maybe forking a repo, it simply means making a copy of someone else's repository into your own GitHub account. So like this is like we basically do this in that's on GitHub. So you have to go to the platform that's on the web app and then do this. So you see someone's repo and then you want to maybe have them in your own kind of repository. So you can use this forking option to put that particular repo into your own and then maybe make any changes you want to make to it. And then whenever you fork, any change you make to that repository won't reflect on maybe the owner's own. You're just like kind of trying to make a copy of what they have into your own GitHub account. So and then you can now make any changes you want and then experiment with whatever code you want that they have. So and then we also have what we call a pull requests on Git. So like I said before now, like when you fork, whatever changes you make to a particular, maybe to the codes and the likes, you won't be able, like all of those changes won't be able to reflect on the user's repo. But then like Git also gives us the option to ask the owners of maybe whenever, maybe like you see the person's codes and maybe see what they've done and then you feel like, okay, I can do something to contribute to this project. So like Git also gives us the option to let those maybe owners maybe allow the changes we've made to reflect on on what they have. So that's like kind of what we call a pull request. So like if you try this out on that repo that you've made changes to, like it will now let the owner of that repo to maybe see what you've done and then maybe to decide whether they should allow the changes you've made to reflect on the original code that they had, the one you forked from. So that's another functionality that we have. So and just like I said, like you are just simply forking, like kind of maybe making a copy of someone else's repo. So like making a copy of someone else's repo. So like let's say for example now you go to a maybe someone's GitHub account and then you are seeing like maybe 100 repos and then you'll be like, this person don't go far. Like most times it could still be like maybe repos that people maybe just forked into their own, that's to their own base, maybe to work with or play around and the like. So forking a repo doesn't mean you own it. So it's just someone else's work. So we'll still get to see this. Or do I have something? I have to minimize. Okay, we'll see that later on. Okay, so a pull request, we've already talked about this. So it's like asking your team, maybe like asking a team, maybe the owners of maybe a particular repo to look at the changes you've made in your separate version of the project, and then to consider if they could add those changes or not to their main projects. And then if they feel good, if they feel good about your work, they can now merge your code with their own. And then if they don't like it, they can discard it and close the pull request you've made. So why do we use Git and GitHub? It helps us to share our files easily among the public. That's kind of open access. Anybody can access whatever whatever we've done, and then maybe learn from them or make changes, and then maybe probably even improve on them going forward. So it enables if it's kind of maybe it's a good way to make our work open access to everybody you get. So like as you go deeper into bioinformatics, like you get to see why GitHub is very, very important, because like you get to see what the builders of the tools you use on a daily basis like kind of maybe did to arrive at those functionalities, um that the that you kind of maybe use to do different projects. So you can also maybe learn from them and then be inspired to even work on maybe a tool or maybe work on a project. So apart from our local computers, it's it also works across your servers to GitHub and blah 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 going forward. And then to back up whatever you do. So if sorry about the noise. So let's say for example now, maybe my system crashes today, and then I lose all the files that's to my projects, all the scripts I've written. So as far as I like kind of kept all of them on GitHub or documented it, like it's still there on the cloud, and then you can always access them maybe anytime you want, and then continue. Do I have a question? No question. Okay. So most software we use is maintained and distributed as Git repos. Yeah. So like all the like common most of the software like that we use anyways are kind of on GitHub. The bioinformatics tools that we run are mostly on GitHub. They're always like for example now like just like this morning that's actually a tool that I've been keeping track of like for a very long while now. So like if you want to maybe like kind of see like how maybe what they do. Like most of them like actually like kind of maybe even updates their work weekly, monthly, like some even like kind of even daily self. Like a tool like Snake Make, like for example, now like it's which is like managed by like kind of hundreds of people. Like if you go over there now, like you always get to see like maybe all the changes that they made, maybe to make to maintain that particular tool. That's kind of frequently. So okay, so we'll be going over the installation of Git on our system. So so depending on what PC you are using, if you are using Windows or Mac, so we have like commands that we can use to install Git. Although you can also install locally, that's kind of download it from this link we have here. So I'll still share the slide at the end of the day. So you can use this link to download this and then install on your system, or you can do it still on your terminal. So if you're using a Mac, you can simply do bring install Git to be installed. If you're using maybe Windows, Linux, these ones can also work. You can also use conda to install. So sudo apps install Git, conda install Git, and like all of these things should work. Or maybe just in case sudo doesn't is not working on your system, you can also install maybe kind of install them and then try the command. If you have conda installed, you can also use conda to install, and then that's it. You can check this link out later on for that if you get to read the kind of the documentation on GitHub on Git. Okay. So you can also download GitHub repos as zip files down to your system too. Um, so which is what you can also do. Which Yeah, so you can also download this straight to your system. That's from GitHub as well. Yeah, so that just don't mind the big grammar. Okay, so for your terminal here, so I have Git installed already, so I don't need to um do that again. So once we've installed Git, so either using brew install or using conda or sudo apps. So the first thing you need to do is to set it up with your GitHub username and email. So first things first, like if you don't have a GitHub account, now it's like the perfect time to go and create it. So you just go over there, github.com, sign up, and then make your account with your username and then your email, of course. So once you have that, then you can now come down to your local that's to your terminal that's back here to set it up. So I'm just going to go ahead and copy, although I've made it already, but I'll just go and copy it and or should I just leave it? It's not necessary, right? So but then once you've installed Git, and then you can always check the version of the Git you have. So I have version 2.46, 2.46. So that's the version I have. So like once you have Git installed already, so you can now set it up. So without setting it up with your username and password, which like during which like while doing that, it's like kind of maybe still ask you the password to your this GitHub account just to be sure. So once you've done that, you can now go on to start keeping track of whatever thing you make as far as you call on Git to do that for you. So git config hyphen global user.name is what you'd use to configure kind of your name on that account for that's on Git. So just type this here. I can't copy this now. I need to exit. I'll just do it anyways. If I want to configure, this is the command I have to use. So you just replace this with your own username and then you run. So if I now want to confirm if this works, I just have to run this code again without my username to confirm if I've saved it. So which is this successful. So then for my email, same thing. So configured. So whatever changes I start making from now on would always reflect on and then, like once as far as I add, commit, and push, whatever changes I make would always reflect on my GitHub account if I log in. So like if GitHub is still seeming strange to you, so this is like kind of this is like kind of what it looks like actually. So this is like kind of GitHub, like this is like the home page or something. So like this is the stuff I was talking. This is Snake Make. So this is like kind of the owner of the two. So like Snake Make is like kind of a workflow management tool that you use to kind of kind of build pipelines and workflows in bioinformatics, just like Nextflow too, if you know that. So this is like kind of the owner, kind of always kind of putting one or two, contributing to the project. So you can keep track of like all of those things, like if you want. So it's like kind of almost doing it like every day, kind of making changes all the time. So this is it. So like once you make your maybe you create your account, you can always go to your profile and then make new repos and then do a whole like kind of other things. Yeah. So this is it. Like this is my my homepage on GitHub. So my username, this is it. So whatever username you use while creating your account, so that's what you're going to use while configuring your Git on your local system. So that is it. I'll move forward. So, and just like what we did earlier, I said it earlier on about making a copy of other people's projects on GitHub. So, like the command to do that is git clone. So, whenever you see maybe someone's project on GitHub and then you want to pull it down to your local computer, maybe to play around it. So, all you need to do is to copy the link to that that repo and then clone it down to your system. So which is this? So this is a bioinformatics tool called SecTK, which can use to play around. I use to play around FastA or FastQ file. So if I want to maybe install it to use or maybe to make changes to it and then to maybe add new things to it and then still maintain its original functionality, I can always clone it down to my local computer and then work with it. So all I need to do is to just copy the link to it. That's copy the link to the repo, which is this. Just come here, code, copy it, and then clone. So if I decide to do that, I can just say git clone, and then I paste it. And then once I do that, it will be cloned into my system. So that's SecTK. So I can call on SecTK to do anything I want to do on my system. Maybe count DNS sequence, maybe do all these what are the functionalities again? I can't remember again. So you can use SecTK to convert FastQ to FastA. You can make what is it called again? You can convert multi-line FastQ to four-line FastQ. You can make the reverse complements of sequences and do like lots of other stuff. So like it's actually like kind of does a lot. So like if you read the documentation, like you should be able to know like the different kind of stuff that SecTK does. So you can clone into your system and then make use of it. But that's not like what we're trying to do. Like we'll still like run tools as much as we want going forward. Okay, so that's it. So initially I mentioned forking a repo, which is simply making a copy into your GitHub, not like into your local computer. So like I have my GitHub accounts. These are the kind of the repos I have. So if I decide to fork, maybe to make like as you can see now, like I don't have SecTK maybe forked into my repo, into my list of repositories. So if I want to maybe make a copy of it inside my list of repos, I can always come here and fork that particular project I want, and then I just need to click here. This is fork. So once I click on fork, repository name, yes, SecTK, create the fork. I think I can even rename it if I want, but then I'll just fork it, create fork. So once that is done, I would make a copy of this in my own list of repos. So if I come here and refresh, I had 12 repos here before, so I now have 13. Where's SecTK? So, okay, so this is SecTK here now. Already in my system, so I can play around it. But then whatever changes I make to this won't reflect on the original SecTK that the actual developers put together. So please, do you have any questions so far? If you have, you can unmute and ask now. Any questions? Does that mean we are following? If you are following, you can say yes or maybe a thumbs up. Okay. Okay, so common ways to work with Git repos. We've covered like most of these already. So you can create your own GitHub repo. So and then you can push that's whatever maybe directories you have in your local system to GitHub. or you can pull, or should I say that's just like the cloning that we did. You can take repos from GitHub to your local computer, and then you can also push from your local computer, down to GitHub. Um, so we'll get to see the first one shortly, how to um push changes down to GitHub. So okay, we've talked about some of these. Okay, I think we should just go to the basics. So remember, initially we mentioned the workflow that we use in that's for Git. So in your list of repos, sorry, in your working directory rather. So whatever file you have there, and then you want to push them to GitHub, you have to use kind of a series of commands that should work, that should take care of that. So first of all, you have to add. Once you add the files that you want to push to GitHub, that is staging them. You can now commit and then push to GitHub. So let's get to see how that works now. Okay, so first things first. So whenever you want to maybe kind of commit some files or that you have on your system, so there are like kind of two things that you actually have to do first. So you have to make a kind of a repo on GitHub where you are going to push all those changes to, or all those files to. You get. So the first thing I need to do is I would come to GitHub first, and then I would make a new repo. So don't know if we saw that. So just come to your GitHub account, come here, make a new repository. That is new. So once you click that, you'd see all of these options here, and then you can now start naming. So I can say I'll name it Git Bioinfo UI. So I can use this as the name of a repository which I'm trying to make now. So if I choose this, and then once I click, and then by the way, you can decide to make your repo private. That's, it won't be visible to the public. So I can change that option here. But then let me leave it for now. So I'll leave it as public and then create the repo. So it's now created. So once I have that, I'll now come to my terminal. I'll make another repo here. I call it Git Bioinfo UI. And by the way, I mustn't name it the exam. Sorry, I mustn't like kind of use the exact stuff I used, kind of the name I used on my GitHub. I can change it. The main thing is that okay? Like whenever I want to maybe push stuff down to GitHub, I always have to kind of push it to this particular repo, which I named as Git_Bioinfo UI. You get, but then for your terminal, you can always use any name you want. So we can use, let's say, Git tutorial. So I have that already. So let's go inside Git tutorial. Okay, so I have nothing here for now. So let's just do a simple kind of just a simple example of how we can create files and then push them down to GitHub. So the basic syntax for working with Git on the shell is this. So you call on Git, specify the command, and then maybe whatever other options that that's for example now. Anyway, don't mind this for now. So like this Git help, if you run Git help alone, it's just going to kind of maybe show you like the different things that you can do with Git. So you can always come and read up this documentation. So Git clone, Git init, add, move, restore, and a whole lot of other things. So okay, so this is syntax, Git, and then the option or the command, then maybe other things that could come after it. So the first thing I have to do here is now that I've made sorry, now that I've created my repo now, my repository, and then I'm now inside the work kind of the direction that I want to maybe work on as to push the changes to Git. So the first thing I need to do is I need to initiate this particular repo. So there's something we call initiation. So like just like kind of initiating somebody to, maybe should I say, I don't want to use code, but let me just say code, maybe, or to any organization, or maybe to a party now. So this has its rules. So you have to initiate first of all. So with the command git init. So once I enter git init, I'll automatically be kind of be activated, or my my repo will now be activated, to now start maybe making changes, and then adding files, and then pushing to GitHub. So that is the first step. You have to initiate with git init. So once I do that, the next thing I'd have to do is to start adding maybe files, and then committing them, and then pushing them to GitHub. But then for now, we don't have any file. This is just an MC repository. So let's create a file. So that maybe like for a starter, let's just create a README file. So I would create this file. So let's just call it like a README, but like normally like on a normal for whichever repo, or maybe a project you are like kind of maybe working on that you want to put on Git. So just for for the sake of good practice, and then reusability, like it's important to have what we call a README file. So like a README file is like kind of maybe something you use to document, what you do, such that let's say for example now I build a tool and I want to to show people how that tool works, maybe the commands you can run, or documentations on how they can navigate things. So it's inside this Git README file that you can add all the instructions, all the documentation that you want to add, or maybe instructions. So this is like kind of where we add all we want to add, and then we can now put them to GitHub. So we'll create that for a start, and then push it to GitHub. So touch README. So I've made my README file now. So once I make that particular file now, I can't push to GitHub until I stage it. So what's the command for staging? So it is git add. So I can just simply say git add. So I can either use a dot to specify that I should add everything in that repo, or I can still call on the name of the file too. So whichever way works for me. So if assuming I have like other files within this particular repo, and then I use a dot, everything I have here will be staged to be committed to GitHub. So git add dot will do that for me. So it's the README file is already staged. So this is the README file which I have. So and then along the line on GitHub, or on Git rather, so as you work and then you want to see maybe the status of maybe all you've been doing, or what you're currently doing, you can always use Git status to check. So if I run Git status, it's saying okay, I've not made any commits. I just created a file called README, and that's all. So I just staged it. I'm here to commit. So remember the workflow that we had earlier on. So after you initiate and then you add, which is a means for you to stage the changes that you are making. The next thing you need to do is to commit that file in the hands of Git. So that's the next thing we'll be doing. So I'll now commit them, the changes I've made. So, and always you have to kind of add a message to whatever commit you are making. So if I just do git commit, I don't think it's going to work. So like whenever you like kind of maybe want to commit a particular file, you always have to kind of use kind of use the -m option to pass a message. So the M is just like kind of a message that accompanies the changes you are making. So which is still like kind of a means of documentation. So let's say for example now I'm adding a README file. So it is ideal for me to say that okay, maybe the comments, or maybe the message I want to pass here is that okay, I'm now adding a README file. If I want to delete files, I can add maybe, and then I maybe do the deleting, and then now want to commit. So if I'm committing up maybe for that change I made, I have to still attach a message to say okay, I'm deleting this particular file. So in this particular scenario now, I made a README file. So I can just simply say, okay, the message that should go along with this is okay. I'm making a README file. Maybe added a README file, and that's it. So once I do this and then press enter, my file will now be committed. So the next thing for me now is to push. But then for me to push, I still need to connect kind of my repo to the that's to my GitHub, that's to the online server, right? So like I'm still working on my kind of on my local computer basically. I still need to like kind of connect it to this my GitHub account, which I have here. We get so not just my GitHub account, but then to my repo, the one I made initially, this one that we just made before we started working. We get so I need to connect what I have here to my GitHub repo, right? So this is the link to that particular repo which I made. So this is the link. I'll just go ahead and maybe come here and copy it, or I can still go back on the list of repos I have. If I want to push all the changes to this particular repo, I just need to come and copy the link to this particular repo here. So I would come here and then copy it. So this is the link. So there's a special command to do that. So you just like kind of basically need to do that once to commit it for each maybe each time you are working. So I'll do git the command is remote add origin and then the link to your GitHub repo where you want to push those changes to. So this is just the command. So once I run this command, I'll now be connected to the online server where I want to push all the changes or all the files I'm adding. So if I press enter, it will now be connected. So the next thing for me now will just be to simply kind of add that's push my files or my changes to GitHub and then check if it will reflect. But then like also, so it depends on like there's something we call like I said, we have what we call branches. So normally like we have what is called a main branch and then other branches that you can have on GitHub. So but normally like by default, we have the default like for example on my local computer now, the default branch I'm working on is the merge is the main branch. So let's assume I'm working on maybe another kind of branch. I'll still I just don't want to confuse maybe like much for today. I just wanted this to be like kind of a general overview before I talk more on branch. So when we talk about branches tomorrow, so like I'd kind of maybe properly maybe distinguish what it means to work on maybe on different branches and then switching um maybe in between. But then for now, just know that okay, the branch that we're working on is the main branch, which is the default that we have on GitHub. We get so I can do git branch. So I'm working on the main branch, which is this. We get so sometimes if you want to switch, let's say for example now you're working on maybe a branch called maybe junior or maybe master on your local computer, and then you want to switch it back to maybe the main, which is the default on your GitHub. You can always use maybe kind of another command to maybe change it back to that default, maybe to enable you to work on the main branch and then connect to GitHub. But then just know this for now. We're working on the main branch for now, so which you want to uh, connect to the one we have on GitHub. So once I run this, the next thing for me to do is to just to push the changes I've made down to GitHub, and then that's it. So the command for that is git push. So git push -u origin and then the name of my branch, and then the changes I've made will be pushed. Okay. So I can now go to GitHub and check if it has reflected. So I'll come here and refresh. So I now have kind of a README file now, um, which I just created there. So you get so that's just basically that. So we can now go ahead to maybe start maybe making changes and then committing them to that's to GitHub. So let's say for example I want to add something to maybe this particular README file now. Maybe I will do it here and then it reflects here. So I can simply maybe open that file. I have nano or let me just say echo. I can echo um info UI Git tutorial into my README. So once I do this, so what's the next thing we have to do now? Like if we want to actually push it to GitHub, so it's still the same workflow that we have. So I'll keep showing this. So now that I've made changes to my README file now, so for me to push it to GitHub, all I need to do first, I need to add this right with Git. That is to stage it to be committed. So I'll use Git add. Still README, right? So I'll add. So what's the next thing again? I have to commit it. Okay. Any question? Please, you can go ahead. Do you have a question? Yeah, I guess not. So once you've added, so the next thing is now for you to commit the change you've made. So git commit edited readme. And that's it. It's now committed. So what's the last thing for me to know? So I just need to do git push and push the change I've made. So I don't need to start like once I like for example like all these like all these things I did initially like with the git remote and then with the git push like from new origin main. I don't need to like kind of start typing like I just need to like I just need to like write them once and then subsequently I just need to start adding committing and pushing, adding committing and pushing without the other options which I just need to run first. Because like the other ones are just basically trying to connect the branch that you are working on. So that's just so I can now just do this push and then push that change to GitHub. Okay, so if I come to my GitHub and refresh, so I have the edit I made now, that's on the README file, bioinfo UI Git tutorial. So likewise, you can start, you can, make other directories, add files into them, and then commit them to GitHub. So let's say, for example, now I want to start a bioinformatics project now. So and then I want to, so which requires me to have, my data where I want to store my outputs at the end of analysis, and then where I want to put all my scripts together. So which is like always a good practice. So if you want to work, you need to make your directories, right? So I'll make a directory for my data. I'll make a directory for my scripts. I'll make a directory for my analysis. So which I now have like so far now, they won't be on GitHub. I'm still working on my local computer, right? So before pushing them like okay, let me just clear it. Like for example, like in Git now, when it comes to pushing what you have on your local computer, like you can't push an empty repo to your GitHub. So let's say I have like 10 directories on my local computer, and then just 4 of them have files inside them. And then I go ahead to add all I have inside that particular working directory to get that I commit them to GitHub. If I should refresh my GitHub account, I'd only see all those files that have all those directories that have files within them. So let me just show us what I'm trying to say. So let's say, for example, now for my analysis, I have I'll just make a file inside analysis. Let me just call it outputs dot csv, and then inside my scripts, I'll do scripts. Let me call it script.sh. So 2 files added now. So okay, let me just leave. I'll leave data alone. Okay, I'll just let me just do everything for now, and maybe we can check back later. So I would create something inside data.csv. Okay, so I've made all of these changes now, right? So that was R rather. Okay, I now have output.csv inside my analysis folder. I now have data.csv inside my data directory, and then script.sh inside my script directory. And then I now want to convert push all of this to GitHub, right? So first things first, I need to add the changes I've made to stage them for committing. So all I need to do is git add. So you can either call on them, maybe start calling on them one after the other. That's git add analysis slash output.csv, and then down to your data.csv. But or you can just simply do git add dot to simply commit, add and commit everything you have here. Kind of saves you time. But if you want, you can just be doing data csv, data.csv down to every other one, or you just simply do git add and then add everything just with a dot. So once you enter, they will now be staged for committing. So next thing for me is now to commit them. So git commit, and then I always have to add a message, right? So what message am I going to add there? So added project files, so which is simply that. So I've now committed it. So remaining the final step, which is for me to now push all I've done down to GitHub. So I'll just simply do git push, and then they would all be pushed to GitHub. So if I come back here and refresh, I should expect that all of these changes should reflect on my GitHub. So which is all of this, I guess. So that's just basically it. So like while working, maybe like if you're working like maybe like kind of step by step or day by day. So and then you want to be keeping track of all the different stuff that you're doing. So that is the kind of a good way to to do that instead of waiting to maybe spend 6 months and work on a project, and then at the end of the day you just come and commit everything once on your that's to GitHub, just straightforward without kind of keeping track of all the intermediary files that you're working with. So that's basically it. And then, like I said before, we can also pull the changes that we've made on our GitHub down to our local computer, right? So to do that, we just need to use the git pull command. Git pull. So that's the command you have to use for that particular one. So just like pushing, you are pushing to GitHub, pulling, you are pulling from GitHub. So just think of it in that way. So whenever you want to upload files to GitHub, or maybe upload changes to GitHub, you have to push them. And whenever you want to download changes from GitHub, you have to pull from the online server, your repo online. So let's say, for example, now I enter inside my scripts folder and make another file, because you can also add files on GitHub like the same way you're adding on your local computer. So if I now want to maybe edit my README or add another file inside my scripts folder, I can always still do that here and then make the changes to reflect on my local computer with the Git pull. So here I can add a file, create a new file, and then name it whatever I want. I can say um what analysis.sh. Okay. .sh. So if it's a bash scripting, you can come here and maybe write all the code that you want to write and then commit. So I'd commit. So and then if I press on commit changes, I would kind of maybe see this pop-up telling me showing me the commits kind of message. I can decide to even change it to maybe whatever thing I want the message to be. So I can edit this or maybe just leave it as the default message is. So once I do that, I'll now come and commit the change. So I've now created another file called analysis.sh inside my my scripts folder. So inside my scripts folder on my local computer, like I still have just the initial one I made. So but then for me to now pull the changes down to my local computer, all I need to do is to do git pull the changes, and then you can see from the message one file changed, one insertion, which is the analysis.sh. So it's already added. So if I ls scripts again, I'll now see the change I made on my GitHub in my local directory. So that's basically that's okay. So I didn't plan to cover more than this for today, because the plan for today was just to show us kind of just a general overview of how you can maybe just achieve the workflow of what we do on GitHub. So by tomorrow we'll go a little bit maybe more in depth. Don't be afraid, just a little bit more in depth on like some of these things that we just did for today, and then that should be all. Like we should round up all we have on Git and GitHub by tomorrow. So from today, if you don't have a GitHub account, you can just simply go and make your account, configure your system, and then I have an assignment, kind of a quiz for us today. Okay, we've covered basically. So from tomorrow, we'll do more on this. Look for a report to work with, and then try to see how all these pull requests work, and then that will be just that for tomorrow, and then we'll be done. Okay, I hope I'm not missing any other thing. Please, do you have questions? If you have, you can simply unmute and ask. And then I also forgot, if you want to maybe see what you've done, like kind of maybe a log of all you've been doing on that particular repo, you can use the git log command to see all the changes that you made. So which is this that's the summary here. So whenever you type git log, it's gives you this, like showing you like the hash. These are like kind of just hash codes. Like each commit you make has a code, you know, for it. So the different commits I made and their hash codes, the author. I was the one that did it. Let's assume I'm working in a team that has access to a particular GitHub repo, and then we all make different commits in these files and make changes. Like I would be seeing like kind of different names of people here, the time when they did it, the dates, and you know the time, and then the year, and then what they did from the commit messages. So that is why like kind of adding a message to your commit is important. So this person created analysis.sh, this person made projects file, added the project files, this person edited the readme, and then this person added the readme, just all the changes that you make basically, and then I commit to messages, and then who did it. Okay. I think that's basically what I have for now. Is any question? Please, did you understand? If you have, you can just give a thumbs up if you understood what I taught today. No thumbs up. Hello, can you guys still hear me? Okay. So let me drop the I made a quiz. I'll also drop this on the group chat. So it's basically just a simple quiz for that on what we did today, and then for you to perform some tasks and then submit there's a link to your GitHub repo. So I'll drop that on the call and then on the. My voice seems low. Sorry about that. Thought I was audible. So that's the link to the quiz. So just take the quiz and then drop a link to your GitHub repo once you've done the assignment. So that was basically that for now. So we'll meet again tomorrow if you don't have any other question. So once you're done, you should be able to see your score and all that. Okay. Yeah. Thank you very much. I'll stop recording now.